Chapter 3.5, Rational Functions. Graphs of rational functions may contain features called asymptotes. An asymptote is a value that the graph gets closer and closer to. These features are what determine the end behavior of our rational functions. There are vertical asymptotes, horizontal asymptotes, and oblique, or also called slant asymptotes. A graph may have any number of vertical asymptotes, but it can have at most one horizontal or oblique asymptote. Additionally, a graph cannot cross a vertical asymptote, but it may cross an oblique or horizontal asymptote. Okay, so since the asymptotes will determine our end behavior, or the basic shape of our graph, that's what we're going to find first. To find the vertical asymptote, you simply set the denominator equal to 0. So let's say we had some rational function. Then vertical asymptotes are what make the denominator equal 0. I would just solve the equation where the denominator equals 0 and my vertical asymptote then is this line. Notice it's a vertical line. X equals negative 2/5. So I would draw a dotted line down my graph at x equals negative 2/5. To find the horizontal asymptotes, I'm going to compare the degree of the numerator to the degree of the denominator. Okay, so the degree of the denominator is 1. If the degree of the numerator is larger than the degree of the denominator, there is no horizontal asymptote. So in this case, the degree of the numerator is larger than the degree of the denominator, no horizontal asymptote. However, if the degree of the numerator is smaller than the degree of the denominator, in this case, the degree of the numerator is 0 and the degree of the denominator is 1, so smaller than the degree of the denominator, there is automatically a horizontal asymptote at y equals 0. If the degree of the numerator is the same as the degree of the denominator, in other words, like this, the degree of the numerator and denominator are both 1, then there is a horizontal asymptote at y equals whatever the coefficients of those degrees are, 3/5. Okay. There will be an oblique asymptote when the degree of the numerator is 1 larger than the degree of the denominator. So for example, if the degree of the numerator was just 1 larger than the degree of the numerator, I'm going to do synthetic division. So I've got a missing term here. Be careful. 2, 0. So I've got to tell the problem now. I'm going to do synthetic division. Changing the sign if I need to pull my k out. Bring down to get me started. 2 times 3 is 6. 2 times 6 is 12. And I'm going to ignore the remainder. And this equation right here will be my slant or oblique asymptote. All right, let's actually apply this and look at some questions. All right, here are the steps for graphing your rational function. First thing I'm going to do, anytime I see a rational equation, goes without saying, I need to try to simplify it. But this one won't simplify, so I'm going to find my asymptotes. Okay, to find the vertical asymptote, I'm going to set the denominator equal to 0. So I wind up with my vertical asymptote being x equals 4. As soon as I find my vertical asymptote, I'm going to come over here and I draw a dotted line because it's not on my graph, but it's one of my boundary features of my graph. So x equals 4. Okay, and then to find the horizontal asymptote, I'm going to compare the degree of the numerator to the degree of the denominator. Since they are the same degree, the coefficients will be my horizontal asymptote. So I've got a horizontal asymptote at y equals -3 divided by -1, or 3. So here's my horizontal asymptote. Now, once I have my asymptotes, there's only a couple of things that can happen because my graph will follow these asymptotes off the edge of the graph. So it'll either be shaped like this or this, and then on the other side of my asymptote, this or this. Remember, I cannot cross a vertical asymptote, but it could cross a horizontal. It could come under it and then follow it off the graph from below. So I just need a few points. Okay, points I always want on my graph are x and y intercepts. Okay, so remember, the x-intercept means let y equal 0. In the case of a fraction, for a fraction to equal 0, the only part I'm really interested in is that numerator. The denominator of a fraction cannot be 0. To make a fraction equal 0, the numerator needs to equal 0. So really, this is the equation I'm trying to solve. Or 6 equals 3x, or x equals 2. Now, don't forget, this is a point, right? So it is the point to 0. Come over here and put that on my graph. And then I'm going to find the y-intercepts. Y-intercepts mean let x be 0. So if I plug a 0 in here and here, I have 6 over 4, or 3/2. Don't forget that's a point. When x is 0, y is 3/2, so 1.5. Okay, so I kind of already know what's going on over here. My graph looks like this. It follows this and follows this, going through these points. The only thing I'm not sure of is, does it cross this and follow it from the top, or does it just follow it from underneath? In order to determine that, I'm going to take my function and I'm going to set it equal to this horizontal asymptote, equal to when y is 3. Does it ever equal 3? Okay, let's solve this equation. Get rid of the fraction, multiply both sides by 4 minus x to get 6 minus 3x equals 12 minus 3x. Adding 3x to both sides, I get 6 equals 12, which it does not. So it never crosses that asymptote, meaning I know enough about this side of the equation to draw my graph in. All right, I'm not going to draw more than what I know, but I know it's going to go here, and it's just going to get closer and closer and closer to this asymptote, closer and closer and closer to that asymptote, without ever crossing them. The only thing left is what's happening on this side of my vertical asymptote. Well, I'm just going to plug a point in. 1, 2, 3, 4, 5. Let's plug in f of 5 into my function just to get an extra point. So that would be 6 minus 15, 3 times 5, over 4 minus 5, or 6 minus 15 is negative 9 over negative 1. So I have the point 5, 9. 5, 9. Meaning I now know what's going on in this way. If I want to draw my big all the way across, then I might plug in another point at 10. Let's just do that right quick. F of 10 is 6 minus 30 over 4 minus 10. So negative 24 over negative 6, or positive 4. Again, that's the point, 10, 4. And I can see that, oh, well, there's the shape of this graph. 1 point right here would have been sufficient as long as I don't draw very much, right? I don't know if it comes over here or how close it gets, or if I don't like just a little short piece, plug in an extra point. Okay, let's try it again for this one. Same steps every single time. This will not simplify. Check that first. Find my vertical asymptote by letting the denominator equal 0. So this is factors as 2 minus x times 2 plus x equals 0. So my vertical asymptotes are x equals 2 and x equals negative 2. I have 2 vertical asymptotes this time. Remember, I can have any number of vertical asymptotes, but only one other one. Horizontal or oblique, only one. Okay, now let's find the horizontal asymptotes. I'm going to compare the degree of the numerator to the degree of the denominator. If the degree of the numerator is less than the denominator, like in this one, there's automatically a horizontal asymptote at y equals 0. Okay, so once again, I already know what's going to happen. My graph will either have this shape, following those asymptotes, or this on the edges. In the middle, it could follow like this, or because I can cross this one, it could cross. So I just need a few points. Of course, points I want to find first are my intercepts. So to find my x-intercept, I let y equal 0. For a fraction to equal 0, the numerator has to equal 0. Oh, the only way that numerator is going to equal 0 is if x is 0. So I have the point 0, 0. That actually gets both of my intercepts, and it tells me that it crosses this horizontal axis, and I know it doesn't cross it anywhere else, or I'd have another x-intercept, right? There's nothing else on that axis. So I just need a couple of points. I need one to the left of my vertical asymptote, between my vertical asymptotes, and to the right. So to the left, I'm going to plug in a negative 3. Here's the one we're working on, right? So f of negative 3 is negative 3 over 4 minus negative 3 squared is 9. So this is negative 3 over negative 5. That is the point, negative 3. Oh, that is the point, negative 3, positive 3/5. So negative 3, positive 3/5, about right here. So I know that's what my graph looks like on that side. Okay, now let's plug in a negative 1. F of negative 1 is negative 1 over 4 minus negative 1 squared is 1. So negative 1/3. This is the point, negative 1. negative 1/3. Now, right here, I don't really know if my graph touches and goes back or if it crosses and goes up, so I need another point. Let's plug in f of positive 1. And I get 1 over 4 minus positive 1 squared is 1. So positive 1, positive 1/3. Now I know what's happening here. It's going to curve like this and follow those asymptotes off the edge. One more point to get in this section. Let's do f of 3. Plugging in, I get 3 over 4 minus 9, or 3 over negative 5, which is the point 3, negative 3/5. Now I know what's happening here because of my asymptotes. All right, let's try that again. Okay, first thing I want to do is see if my function will simplify. So x plus 2, x minus 2 over x plus 2, x plus 1. Oh, yes, this simplifies to the function x minus 2 over x plus 1. So these are where I'm finding the asymptotes. However, there is not an asymptote when x is negative 2, but there is a hole in the graph. This graph must be the exact same graph as this because these are equivalent fractions. They're equal. The only exception is this one will have a hole in the graph at x plus 2. It won't be a different shape. It won't have an asymptote there, but there will be a hole because technically plugging a 2 in would make the denominator of this one 0, but not this one, and we can't have that. So I got to remember that there's going to be a hole at x equals negative 2. Okay, so now on to find my asymptotes. My vertical asymptotes are what makes the denominator 0. So I have a vertical asymptote at x equals negative 1. Okay, horizontal asymptotes, I'm going to compare the degree of the numerator to the degree of the denominator. Since they are the same, then I have a horizontal asymptote at 1 over 1, which is y equals 1. All right, and just like that first one we did, there's only a couple of things that can happen. My graph is going to curve here or here, and then it's going to curve here or here. So some points to help me determine that, and definite points I always want on my graph, x and y intercepts. X-intercepts means let y equal 0. For a fraction to equal 0, the denominator needs to equal 0. So factoring this or using your square root method, we find that x equals negative 2 and positive 2. Now remember, these are points. So this is the point negative 2, 0 and positive 2, 0. Excuse me. Y-intercepts is when x equals 0. So if I plug a 0 in to my function, I get 0 minus 2, so negative 2 over 1, which gives me the point 0, negative 2. All right, over here I'm pretty good. There's only one thing left I need to know before I draw it in. Does it cross this line and follow it from the top, or from underneath. In order to determine that, I'm going to take my function and set it equal to my horizontal asymptote. All right, so solving that equation, let's get rid of that fraction. So x minus 2 equals x plus 1, subtracting x, negative 2 equals 1. No, it does not cross it. I'm good to go on this side. I'm actually good to go on this side also. Now don't forget, there's a hole when x equals negative 2. So this point right here needs to be drawn as a hole. Because I know it does not cross the asymptote, it's going to follow it this direction and that direction. Okay, let's try this one. Let's just erase it all. I was going to leave that up there, but you can pause it. Hopefully that's what you do when you watch these. Okay, so let's see if this thing will simplify. First thing, are there two numbers that multiply to give negative 4 and add to give negative 5? No, right? Negative 4 and 1 is not negative 5. So I don't have to worry about that. So let's find our asymptotes. Vertical asymptotes are what make the denominator equal 0. So I have a vertical asymptote at x equals 2. Checking for horizontal asymptotes, I check the degree of the numerator with the degree of the denominator. If the degree of the numerator is bigger than the degree of the denominator, there is no horizontal asymptote. However, if it's only bigger than 1, there is an oblique asymptote. So to find the oblique asymptote, I'm going to do synthetic division. And I'm going to divide these two polynomials. Okay, bring the 2 down. 2 times 2 is 4. 2 times negative 1 is negative 2. I don't care what the remainder is. Here's my oblique asymptote. Y equals 2x minus 1. So I got to be able to graph that slanted line, right? My y-intercept is negative 1 and a slope of 2, up 2 over 1, up 2 over 1, up 2 over 1. Or down 2, backwards 1, down 2, backwards 1, down 2, backwards 1. So there's my oblique asymptote. So same thing. Either my graph follows these, or it follows it in here or in here. So I need a few points. Let's get the x-intercepts. X-intercept is when y equals 0. So I'm going to set 2x squared minus 5x minus 2 equals 0. We already said this thing doesn't factor. So I'm going to do my quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So 5 plus or minus the square root of 25 plus 16, so 41 all over 4. So the square root of 41 is the square root of 36 is 6, square root of 49 is 7. So that's between 6 and 7. Let's say we have 5 plus 6.5 over 4 and 5 minus 6.5 over 4. So 11.5 over 4 or what is that? Nearly, let's just do an approximate. 12 over 4 is a little bit less than 3, right? A little bit less than 3. Over here we have negative 1.5 over 4. So a little bit less than, if that were a 2, negative 1/2. Okay, so I've got at a little bit less than 3 and a little bit less than negative 1/2. Okay, so basically I know what's happening over here. It's following it here instead of in here. Except, does it cross it and go up, or does it just follow underneath? So let's take the equation, the function, and set it equal to the asymptote. Getting rid of the fraction. I have 2x squared minus 5x minus 2 equals 2x squared minus 4x minus 5x plus 2. Subtracting the 2x squared and adding 5x, I wind up with negative 2 equals 2. It doesn't cross it. I know what's happening here. Right? I know what's happening here. And I know what's happening in here. Whoops. Now, look at this. I'm going to erase that. I was getting a little carried away there. Okay, there's my point. So it must just, I don't have another place where it crosses over this. So that must be where it touches. Let me make sure that 1/2, maybe, oh, maybe that's on, no, it can't be on it. We said it didn't cross it. So let me get another point in here. Let's just, to see what's happening, let's get a point when x is 1. So let's plug in to my function when x is 1. So I have 2 minus 5 minus 2 over 1 minus 2, or negative 5 over negative 1. Oh, look at this. Negative 5 over negative 1 is positive 5. This is the point 1, 5. I'm up here. Okay. That point, let me re-look at that point. I think what's happening is our line here is drawn a little askew. Let me redraw this part of my line. I'm going to draw some more solid, a more solid line there. I'll go in and erase bits of it. Okay, negative 1. Okay, so up 2 over 1. That 1/2, yeah, that 1/2 goes right through my asymptote, the 1/2. So when our point was a little to the left, oh, it's negative 1/2 anyhow. We didn't even, I was going to say it was a little to the left of negative 1/2, but it's not even 1/2. It's negative 1/2, right? Negative 1/2. There's our issue. So I've got a point over here at not quite -1/2. And we've already determined it doesn't cross this line, so I know what's happening over here. It's following that asymptote just like that. Okay, and think about this. Your graph doesn't even have to have an asymptote, right? Suppose we had the function f of x equals, oh, let's do something simple. 5x squared plus 2x over x. First thing I'm going to do is simplify that. So I'm going to factor out the x and make it 5x plus 2 over x. So really, on this one, I'm just graphing the line 5x plus 2, but I've got to remember there's going to be a hole at x equals 0, right? Whatever makes this denominator 0 can't be a part of my graph, but it must be, since these are equivalent fractions, it must be the same shape. So I'm just going to graph this line, remembering when I plot my point when x is 0 to put a hole there. So my y-intercept is 2. My slope is 5. Up 1, 2, 3, 4, 5 over 1. Down 1, 2, 3, 4, 5. Backwards 1. And remember, when I draw through when x is 0, put a hole there. Just imagine that I can draw a straight line with this thing, which I cannot. Okay, so may not have asymptotes. May have multiple vertical asymptotes. May not have any. But if it does have asymptotes, I have to have them on my graph. Important features of my graph. Okay, let me know if you have any questions.